In this question, a man swimming in a river from point A on one bank has to reach a point C on the other bank, which is at a distance L from point B, directly opposite to point A on another bank. River width is D and current velocity is u naught. Find the minimum speed with which the swimmer relative to still water so that he should swim. Okay. So in this case, suppose this is the river, point A, and there is a point B opposite to it, and from A the swimmer is supposed to reach this point C, and this point C from B is given at a distance of L. The width of the river is given as D, and and the velocity is in this direction, that is given as u naught. So let us suppose, so what we want that the swimmer should reach point C. So the direction in which the swimmer swims, let us call this as this direction, AC prime, which is at angle theta with the vertical with the line AB, and this will be the mu naught, and u, or rather we can say v, is the velocity with which the swimmer is swimming. X-axis, and let us suppose this is y-axis. So we can divide the velocity of the swimmer v in two directions, rather in two components. Vx will be equal to, in x direction will be equal to v sine of theta, and Vy will be equal to V cos of theta. So if t is the time taken by the swimmer, okay, we can say if t is the time taken by the swimmer to cross the river, then so we have two components, velocity components. In this direction it is u of x, and in this direction it is u of y. Then the effective velocity with which swimmer will cross the river, will be equal to v of y. Okay, because this is the only velocity which is acting in the vertical direction. So we can say that time, thus t will be equal to d divided by vy, and vy we already know is given as v cos of theta. Next will be the drift of the swimmer. Drift of the swimmer will be nothing but distance BC, which is given as L. So we can say that L will be equal to ux plus u naught into time t. Ux is v sine of theta plus u naught, and time we already know is given as d divided by v cos of theta. This is L. From here we are going to find out our v. So we can see that v cos theta will be equal to u naught d divided by L minus d tangent of theta, or v will be equal to u naught d L minus d tangent of theta multiplied by cos of theta, and this can be further written as solved as u naught d divided by L cos theta minus d sin theta. Okay. Now we found it is asked that the velocity should be minimum, so we can say v will be minimum if its derivative with respect to the angle is equal to 0. So you can say that minus L sin theta minus d cos of theta is equal to 0. Okay, so we get this as L sin theta is equal to minus d cos theta, or tangent of theta is equal to minus d upon L. From here we can find out sin theta as well as cos theta. So you can say sin theta will be equal to minus d divided by L square plus d square, and cos theta will be equal to L divided by L square plus d square and its square root. So substituting the values, we get v minimum is equal to mu naught d divided by L into L square plus d square and its square root plus d into d, and we get L square d square and its square root. So we can write this equal to mu naught d multiplied by square root of L square plus d square divided by L square plus d square. Now we rationalize it, or we can say try to solve it further, dividing and multiplying by square root of L square plus d square. So this will be equal to mu naught d L square plus d square divided by L square plus d square into square root of L square plus d square. This cancels out, so we get v minimum is equal to mu naught d divided by L square plus d square and its square root. So this is the minimum velocity with which the swimmer should be swimming so that it reaches the point C. Thank you.